We are asked to prove by mathematical induction that 5 to the power of 2n minus 2 to the power of 3n is divisible by 17 for all answers where n is a positive integer number. The idea behind mathematical induction is to prove a pattern, whereby if we have one situation, so the value of n equal to 1, then if this is true, that the next one will be true when n is equal to 2. The idea is a little bit like dominoes, where if you have the first domino that falls, it will cause the second domino to fall and continue. However, as this is maths, we can't just assume that, hey, if it works the first 3 times, then it's going to work every time. We have to do it in a general case. So we need to prove 2 things. One is that if a domino falls, will the next domino fall? So if one case is true, will the next case automatically be true? And then we need to prove that the first domino will fall, so the base case is true. And then with those 2 things together, we can say that, well, then this statement is true. We know that if one case is true, that the next case was true, and continue. So these are the 2 patterns that we need to prove. Going back to the question, we need to do 2 things to answer this question. We need to prove the base case. It's generally nicer to do this part first as it's easier and there's marks for it. And then we need to prove the pattern, so prove the general case. So first of all, looking at the step 1, proving the base case. So this is when n is equal to 1. Simply substitute this into the formula that we have. So we have 5 to the power of 2 minus 2 to the power of 3, and we calculate it out. That's equal to 25 minus 8, which is 17. Therefore, n equals 1 is true, and it is important to write this statement. Now for step 2, to prove the general pattern, we need to do 2 things. First of all, we need to declare that we are assuming true for n is equal to k. So we are assuming that 5 to the power of 2k minus 2 to the power of 3k is equal to some multiple of 17. So we write 17 times s. We have to explicitly say assume true. Then we consider the next case. So consider n is equal to k plus 1. We put k plus 1 into our equation. So we have 5 to the power of 2 times k plus 1 minus 2 to the power of 3 times k plus 1. We multiply out the powers. So we end up with 5 to the power of 2k plus 2 minus 2 to the power of 3k plus 3. Now from our laws of powers, you know that if the powers are added together, this is the same as the bases being multiplied. So we have 5 to the power of 2 times 5 to the power of 2k. Similarly, we have minus 2 to the power of 3 times 2 to the power of 3k. Multiplying this out, this is 25 times 5 to the power of 2k minus 8 times 2 to the power of 3k. The big step that will generally happen in proof by induction equations is to figure out how to split up one of these numbers so that you can extract out the n equals k part. And so we can split 25 5 to the power of 2k's into 17 5 to the power of 2k's plus 8 5 to the power of 2k's. And then also add in the minus 8 times 2 to the power of 3k. We therefore have 17 times 5 to the power of 2k is equal to factorize out the 8. So you have 8 times 5 to the 2k minus 2 to the 3k. And lo and behold, that was equal to our previous case, where we have assumed to be true that that's equal to 17 times s. So now if we substitute that all in, we've got 17 times 5 to the 2k plus 8 times 17s. If we factorize out then the 17, you've got 17 times 5 to the 2k plus 8s. This clearly is a multiple of 17, as it's multiplied by 17, and so this is true. As this is true, based on the previous fact that n equals k is true, we can then say that the proof is true for all n is a positive integer. Thank you so much for watching. I hope this tutorial made things clearer and helped you tackle this question. Don't forget to like, subscribe, and hit the bell to stay updated when more questions are answered. If you have any questions or need any more help, please drop a comment below and I will get back to you. Until next time, keep practicing and good luck.